Thanks, Jonathan, and welcome everybody. Delighted to see so many of you here in the audience in the lecture theatre here today. And I know there are quite a lot of people online in the audience virtually as well today. So welcome to all of you who are joining us in that format. This is the 10th session of Discovery Days 2024. And for those of you who haven't been here to date, the format of these is that each of our three members of the university community presenting will give a 15-minute or so talk on their area of research or interest or activity, following which there's an opportunity to ask questions in a kind of panel discussion that will take place at the front here. So if you're in the audience, please think about those questions and hold them in your mind until the end of the session. And for those of you who are online, please feel free to post questions into the chat, and John will pick them up and pass them to me so that your questions can be asked in the room here later on. Without further ado, we'll move to our first presenter this afternoon, who is Professor Anne Coxon, who's Chair of Practice in Forensic Sciences here at the university, and who is also Deputy Director of our renowned Leverhulme Research Centre for Forensic Sciences in the School of Science and Engineering. Before coming to the centre in April of last year, Anne spent 8 years at Forensic Sciences South Australia in Adelaide, where she was Assistant Director for Operations. She's got 20 years experience as a technical expert and science leader within a field known as clandestine drug laboratories. She gained that while working for the Institute of Environmental Science and Research in New Zealand, and she's been awarded life membership of the Clandestine Laboratory Investigating Chemists Association in 2008, and has held elected positions on the board of that association, including being president in 2012. She's delivered training in this area to forensic chemists and enforcement officers in countries around the world, and published the results of her research in the field really widely. So we're delighted that Anne's joined us, and we'll invite her to give her presentation entitled "You Think Forensic Science is Sexy?" Anne.
Thanks, Jim. Good afternoon, everybody, and thank you for attending, either in person or online, particularly for the after lunch on a Friday afternoon dreaded session. So title of my talk is "You Think Forensic Science is Sexy?" As Jim mentioned, I've only been at the university since April, and my role doesn't actually have a remit of direct research to be delivered on, but I work within the Leverhulme Research Centre for Forensic Science, where I bring my operational experience to ensure that the work, or to assist in ensuring that the work from that centre meets the needs of the clients, that answering the right questions in the right way, so that the outcomes will be accepted within the community of forensic science, and ultimately with the goal of ensuring that the science that is presented to the courts is the best that it can be, that it's robust, that it's accurate, and most importantly, that it's communicated to the courts so the court can understand it. So I provide that role between academia and reality, operational practice. One of the things the centre is particularly strong on is public engagement and public education. It's the public that make up the juries in courts, and those juries are responsible for making those justice decisions around guilt or otherwise within that court setting. So it's actually really important that juries have a realistic expectation and at least some understanding of forensic science, whether that's before they go into the courtroom or once they're in the courtroom, is it explained to them in a way that's understandable? There are a lot of misconceptions out there, and I blame a lot of these programs. Very entertaining. And of course, you're never going to get the full reality, because realistically, it's not as entertaining as the way they portray it. Started off with the CSIs, and of course the CSI Miami, CSI New York, CSI Las Vegas, CSI Los Angeles, just to name a few of them, became quite a franchise. But in the middle there, we have Abby, who from NCIS, you've got to love Abby. She's a jack of all trades. You know, within a 5-minute spectre, she's been putting a sample in one end of an instrument. The result comes out the other end, and she'll be turning around telling you, oh, that DNA is a match to this particular individual on the database, and explaining the likelihood that that DNA sample did come from that individual in comparison to any other individual it may or may not have come from. She'll then turn around And she'll say, oh, look, you know, that fibre that you took from the victim, the dye in that fibre matched the dye in the fibre we found on the car that we believe was the hit and run car. Great, fantastic. She's great, is Abby. And then she turns around and looking down a microscope, oh, look, this is a pollen. Can you see? This is pollen from this incredibly rare plant that only grows in one little geographical identification. She's a true jack of all trades, which is fantastic. It's great for the investigators. They love it. It's great for TV. But in reality, it is just not going to happen. And the reason why it doesn't happen is because of the sheer amount of technical expertise, experience, and knowledge you need to be able to work in one of these fields is so vast that it's impossible for someone to work across so many different fields. Sometimes there's a little bit of overlap between ones that use the same chemistry, perhaps, or the same science, but it's not going to happen. And an example of that would be if we look at DNA. When I first started, more years ago than I remember, you needed a blood sample or a blood spot about the size of a 50 pence piece, and that's the old 50 pence piece, before you could get a DNA sample. All the questions in court were around, how sure are you that that's a DNA match to my individual? What could have happened with the science? What could have gone wrong? Are you really sure that's the DNA you're saying it is? Now, just by purely being in this room without touching anything, my DNA could be picked up off a lot of the surfaces in this room, along with a lot of other people. DNA technology has advanced so far that it's got so many complex problems around mixtures of DNA and how they can be separated. So you can find a DNA profile, but also how did could my DNA have got there? Could I have shaken hands with a colleague outside, and then the colleague has come in and touched some of the surfaces with my DNA being on there? So transfer. How long is it going to stay there for? There is so much information that's required. And the questions in court now aren't around the science of the DNA or how a DNA profile was generated, although the scientist still needs to understand that. It's around how could that DNA have got there if the particular individual the DNA aligns to hasn't been in that room. For primary transfer, secondary transfer, tertiary transfer, different surfaces, temperatures, atmospheres. There's so much information to interpret the data from an analytical technique. You just don't get those jack of all trades, as much as an exciting job it must be. And then at the bottom, whatever side that is to you, left to me, we've got Jack. Jack from Silent Witness. Jack is their forensic expert. Not sure expert in what, just forensic expert. I get the impression he's a crime scene expert and then knows a little bit about it. Now, those crime scene experts or forensic scientists that are crime scene experts are experts in recognizing, locating, detecting, and collecting evidence or potential evidence from a crime scene. Jack's fantastic. He walked into a scene the other day. There was, I think it was this week actually, there was a deceased that was believed to have been killed elsewhere and brought to the scene. It was in a room. He walked right into the middle of the room. Oh, yeah, there's a door over there. No, it's too far for them to carry them. Well, that door's a bit closer. Wandered over, looked at the door and said, oh, the deceased was wearing an orange jumper, orange fibres on there. That's where they brought them in. And that was his job done. Job done for the day. Off we go. Crime scene looked at, got the information I need. In reality, yeah, it doesn't quite work like that. You know, that one piece of evidence, there are so many holes in it for a start. Yes, it might be orange fibres. What colour overalls were the first responders, the paramedics that came in to look at the victim, see if they were still alive, perhaps treat them? Were they orange? Could the victim actually have been in that particular room yesterday, the day before, and was drunk and staggered against the doorway on the way out? You know, there are so many things that you don't know, that you don't just go in and assume and find your one piece of evidence and leave. The other thing is you get one chance at a crime scene. There's none of this 2 weeks down the track. Oh, wonder if there was any shoes at the scene. Wandering back, and there's a nice little bit of tape across the door that says crime scene, do not enter. Yeah, that doesn't work that way. You know, it hasn't protected your scene. Your credibility's gone. There is no way you can walk back into a scene three weeks later, even with crime scene on it, to collect more evidence. So you approach a scene methodically, logically, and painstakingly slowly. and you collect whatever's there. At this point, you don't actually know what's going to become evidence. You're just looking for information or pieces of material that potentially could then become evidence to be presented in court. And it doesn't generally just take one or two people randomly walking around looking for different things. There will be a discussion beforehand between usually the police officer investigating or in charge of the investigation, usually a detective or a senior detective, depending on how serious the crime is, crime scenes examiners, forensic scientists, usually a pathologist will be in there, and any other experts or people that are required to bring some sort of technical expertise to that investigation. And there'll be a discussion about how we're going to do it. We're going to start from the outside and walk into the body. We're going to start where the deceased is and work outwards. Are we going to start at the door and logically work on a grid system or across the whole thing? And it is painstaking. And every piece of evidence, you know, there's none of this, oh, here's my tweezers, oh look, pick it up, put in an envelope in my pocket and out I walk because I've got the bit I want. Every piece of evidence is photographed, documented, given a number, so that right from the word go, we know where it's been. It's called a chain of custody. We know where it's been. It's kept that integrity to whatever may or may not happen to it into the future. So it takes a little bit longer than the, 2 minutes you wander in, find the one piece of vital evidence and walk out again. One thing I do really want to talk about, and this is from my expertise, I'm a clandestine drug laboratory chemist, or I was, which meant that we were involved with the investigation of illegal laboratories where people were making illegal drugs, effectively, at home, in motels, in the shed, in farms, wherever it may be, they were making it, and they were making illegal drugs for selling. We worked from crime scene to court, because the police wanted us there. We were an independent agency, but the police wanted us there to assist with the safety of dealing with a lot of these labs. Before I get into the comparison with CSI New York, two things. At a clandestine drug laboratory scene, the two most significant dangers that you're concerned about when you first walk in is one, in an explosive atmosphere or fire, flash fire, and secondly is a toxic atmosphere. So the reason why I pull up this one is because I'm on a number of occasions have seen this occur where Stella Bonacera, who's the character in the middle there, gets called out in the middle of the night. And yes, we were on 24/7 hour on call as well, like they were. We would get called out on average between 2 or 3 times a month in the middle of the night to attend a clandestine laboratory scene that the police had come across. So Stella gets the call, and a few minutes later, and I appreciate it's TV, but it's not that long later because it's still dark. She turns up at her scene, gets out of a car, and before we even get into anything else, the thing that got me every single time was the fact she's standing there with a takeaway cup of coffee. Trust me, at that time in the morning, there is no worthwhile cup of coffee purchasing if you can find a takeaway that's got them. Maybe things are different in New York as opposed to New Zealand, but I never found anywhere that was anywhere near decent before about 7 o'clock in the morning. So she steps out the car and she's wearing, oh, first of all, her hair's immaculate. Makeup, not a smudge on it, looks wonderful. Usually very smart, quite often a 3-piece suit and heels. Fantastic. I'm here to do my work at a crime scene. How does that look like in reality for us? Well, first of all, the phone goes off. Yep, I'll be there. Yep. And we had to respond. We'd be there within an hour, depending on how far the travel was. We had to have actually be up and ready and moved within 40 minutes. So you'd get up. I might comb my hair. Admittedly, makeup was the last thing I was thinking of. And we'd then have to thought about, okay, what am I going to wear to go into this crime scene? My 3-piece suit was not what I was reaching for. The first thing is whatever we put next to our body had to be natural fibers, so cotton or silk. And the reason for that is if you are in a flash fire, you want that material to burn and fall off you. If you have synthetic, it's going to melt and stick to your skin, which is never good. You've got to think about things like, you don't wear jewelry because again, that's in a flash fire, that's going to heat up and it's going to melt or it's going to melt all your skin and cause some very bad burns. But it comes down to, okay, how do you find, for me personally, how do you find a bra that doesn't have metal or plastic bits that hold it together at the back and that is not synthetic? There's a little thing here you have to think about. Next on top of that, you'd either have a cotton t-shirt, or if it was thermal, because it was middle of winter, you would wear it. Again, it had to be merino, it had to be wool, it had to be silk. You couldn't have polyprop because that again would melt and stick to your skin. On top of that, we would put on wool overalls. Wool, again, because they burn and fall off you in fire, but these ones were fire retardant. They were the same level of protection for fire retardant that the racing car drivers, wear underneath those bigger suits they wear that you see them when they're getting in and out of the cars. They wear these underneath to protect them from fire. Put my boots on. Again, it wasn't my heeled boots I was reaching for. What we went for was work boots. So your boots are going to have to be across the bottom. We're going to have metal plates in the soles. We're going to have steel toe caps. They've got to be impervious to chemicals because who knows what we're going to be walking around in on the floor. So you don't want them dissolving, the soles dissolving on them. You don't want chemicals getting into them. So if they did have laces, you had to make sure that the tongues were actually attached. So not a separate piece of lick, because otherwise chemicals will go in through the holes and down onto your feet. So at this point, we would then get to a scene. And when we got to the scene, we would put on our chemical protective suits. Now, these, attractive is not a word that, springs to mind. One size fits all, or one shape fits all, shall we say. They did come in different sizes, all pretty large. Thick, plasticky type material. They weren't plastic, but they crinkled when you walked around in them. They weren't particularly easy to move about. But you'd put that on, and then you would tape, where the zip went up the front, you would tape down over the zip. We would wear two lots of nitrile gloves. Nitrile because latex is going to dissolve in a lot of the chemicals that we had to handle. And on top of that, you would put on gloves that were for protection around sharp implements, hot implements, needle picks. But you had to have a balance between dexterity and protection, because as part of what we were there at the scene for was to make it as safe as possible. So I may have to dismantle things, move chemicals, turn things off. So I needed to be able to move. And then we would tape the gloves to the suit. We'd tape our feet, the boots to the bottom of the suit. Then I put on breathing apparatus with a tank on my back to actually protect me against the atmosphere. Pull your hood up and you get taped in. And that's to stop your skin from being exposed to anything that may be in the atmosphere. And I've seen someone who hasn't taped here properly and then spent all day moving sealed sacks of caustic soda and ended up with really bad burns down through here because the caustic dust in the atmosphere had got onto the skin, reacted with the moisture in the skin and burnt them really, really badly down through here. So we protected ourselves. You might spend anywhere between 10 minutes and an hour in this kit up, moving around. When you came out of that, we went through a decontamination shower. So it's a bit like the fire service turn up with them. They're a bit like, they're about the size of a normal shower unit, but they've got jets coming at you from every corner, all the way up and down. I've done it once without breathing apparatus and never again, because you can't breathe in those things. So you come through, and that other reason for that taping is when you've taken off your outer gear, which could well be contaminated, you see how dry you are. So that tape really does help. And the drier you come out, we used to have a bit of a competition around that, was how it looked at. But at this point, we haven't even thought about processing the scene. All we've done is make it as safe as possible. We've still got that long, methodical process ahead of us of going through the evidence and collecting it and bagging it and determining where things are going to happen and what we're going to do with them. And I have to say, at that point, you're not looking your best. You've been through a decon shower. You've spent an hour inside a sweaty suit with breathing apparatus, moving around, thinking about, gosh, what's going to happen if I move this, turn that off, mix those two chemicals or separate them. But we always used to say to each other, we're not there to look good. We're there to get a job done. So from my perspective, yes, it was fantastic. It was a great career. Loved every minute of it. But was it sexy? I'll let you decide that. Thank you very much.
Thanks, Anne. And can I remind you all to be thinking of those questions you want to ask in the Q&A panel discussion later. And if you're online, please do post them through to John to pick up for you. So we'll move on to our next presentation, which is from Dr. David Booth, who is a senior lecturer in the Darcy Thompson Teaching Unit within our School of Life Sciences. And David is the winner of the Most Inspirational Teaching Award in our 2023 Student-Led Teaching Awards. And I think there's something really special about receiving an award that's been voted on by our students. So congratulations to David for that. The Most Inspirational Teaching Award goes to a member of teaching staff who's engaged and inspired students, who is passionate about their subject, and who's empowered those students to take ownership of their own learning by supporting them and enabling them to maximise their academic potential and create their love for the subject, pushing them beyond their limits and encouraging them to excel. So a fantastic award for David to have achieved. And he's going to talk to us about unknown unknowns and navigating the challenges in training students in statistics. David.
No applause. Publishers said save that to the end. I can't lie, I'm a little bit intimidated. There's a couple of reasons for it. The first thing is, this is my stomping ground. I spend most of my academic year teaching students in this very room, so it feels very strange to have so many interlopers today. I'm not entirely comfortable with this audience just yet. The second thing is, I'm not very dapper. The other speakers have made tons of effort and look amazing today, so I feel a bit underdressed. And this week is all about the bumper crop of profs and thought leaders and, you know, intellectuals that this university produces, and I'm definitely not one of those. And then finally, how do you give a talk about being an inspirational person? This is a big gamble, because if it doesn't work, it means that there's something hideously wrong with the whole thing. So it's my job today to try to give you a feel for, you know, how it is that we instruct students, and probably maybe why it is that I actually got an award, which should be said did not come with any monetary. Very disappointed. And it was a bit of acrylic. The last one I saw was made of glass. But you know, it's the thought that counts, so it's all good. So I'll try to get to the bottom of it. And I like the unknown unknowns component of it, because this really is an unknown for me right now, because I've never given a lecture to my peers or given a little talk to my peers in this fashion. So how do we do this? Well, I believe most people introduce themselves, so it's probably good to start at the beginning. Big things have small beginnings, or so they say. And it's, you know, a difficult childbirth in 1976, or apparently this is exactly what I said to the students, which is that the stork brought me, and that a biologist believes that a child could be magicked into existence. Now, it should be said, the reason why I said this is because I was teaching in 2016 after having broken my leg quite badly, sitting in a chair at the front on quite a lot of opiates at the time. So I'm not surprised that very occasionally strange things come out of my mouth. Now, this is from a little series of, it's like a little picture book that the students produced in 2016. They called it Lecturer Moments. All of the lecturers are included in this little booklet. I've only included myself. I'm not going to bring anyone else down with me, but believe me, that's not the worst thing that's in the book. What are the odds of winning this thing? Because I think I just did it by chance. We got about 1,500 academics. You got a 1 in 1,500 chance. I rolled the giant dice, and the dice rolled up a 1, and I was plucked out of obscurity and plopped down in front of everyone else. I mean, that's possibly what's going on here. This little graph, so these are the odds. So if we look at the far right, that's guaranteed. If we look at the far left, that's never going to happen. Not in our lifetime, not never. If we look at, say, 1 to the -1, that's a 1 in 10 chance. So that gives you a feel for the approximate odds of a thing. I thought it was reasonable to take the odds of randomly winning this and comparing it to other things that could happen in my life, either through effort or just because stuff happens. So let's have a look at some of them. Remarkably, winning the award, I'm as likely to become an astronaut. Of the 18,000 odd candidates that put themselves forward for NASA astronaut training, and they had 10 selected, so the odds are pretty similar. I am an astronaut. Yes, that's true. As we all know, we're about twice as likely to win this award as we are to navigate an asteroid field. 3PO quite clearly told us the odds were 3,720 to 1. And Anne reportedly immediately said, don't tell me the odds. The likelihood of getting chomped by a shark is about, 10 million or so, 1 in 10 million or so. The one that really surprised me when I was looking these up was the possibility that you have a doppelganger somewhere else on the planet, someone who has your exact face. This has been studied by scientists. So researchers in Adelaide measured about 4,000 odd people. They took the morphometrics of these faces and they determined the likelihood that there would be 2 people on the planet that have the same face. This is the least likely thing that can happen to you. It's about 1 in a trillion or so, approximately. And of course, I'm inspirational, but I can guarantee at some stage I will be expirational. The one thing I can be sure of in my life is that I'm going to expire. Probably, well, I hope not soon. And I don't want to do it on stage right now, because a lot of actors and comedians and whatnot expire on stage and people don't realize that they're doing it. They think it's a joke. They think it's part of the act. So hopefully that won't happen here. So is it a black swan event? Did I win this just by chance? Or was there some effort? Did something happen? Was there some series of events that came into place? Was there something to it that was more than just a roll of the dice? I'm going to hopefully show you what it is that we do at Dundee that maybe might explain why it isn't just a roll of the dice. Now, where did I come from before I came here? I did a PhD at Queen's University. It was fish biology. It was primarily actually not too far from your domain. It was forensic science applied to wild organisms. I really took to that like a duck to water because it got me out of the lab. I got to learn new things. There's me up in the top left-hand corner, sitting on the bank of a river up in Fermanagh. Or was it Donegal? I forget. It's one of the two. It was a long time ago. And the thing to my left is a thing called an electrofisher. That's a battery pack. It's got a car battery in it. And you have a big sort of metal fishing rod and a big long metal tail. And you walk down the river and click the button and it sets up an electric field and the fish swims in. No effort required. Least effort required in fishing ever. The worst thing that can happen is because there's a very heavy battery pack is you fall into the water and you hurt yourself, and you do quite frequently. So a bit of a risk taker, even at that stage. I decided to do that PhD, not really knowing much about DNA profiling, so I took a bit of a risk there as well. And I was quite pleased that I did. Doing a PhD means you get to go all over the world, especially if you can do a conference somewhere neat. And in the final year of my PhD, I found a conference in Hawaii, so I managed to get out there on the university's dollar, which was great, for 3 weeks. Now, most conferences only take 4 days or 3 or 4 days, but for some reason they believed that I needed to be there for 3 weeks. And that's me at the Kilauea volcano in the south, sort of the south of the Big Island, watching the lava go into the Pacific Ocean and the black sand and the huge cloud of hydrochloric acid, kind of coming off the top of it. So I love taking risks. The interesting thing about these little images is it applies alt text to all of these automatically, which I find bizarre, because the alt text for the thing on the left, the top left, is man standing in grass. Now, I am clearly not standing in grass. So we probably have to work on the artificial intelligence that's kind of identifying what's going on there. Okay, so that's my academics. My academics is very much an ecologist with a genetic bent, but as running in the background, the RAF trained me how to fly planes. So I have a couple of 100 hours worth of flying light aircraft. Love that, but it also exposed me to the way, like a training system that's world class. It's the thing that takes, about 3,000 applicants a year and puts them in a fast jet eventually. The odds of you getting to a fast jet going through that route of training is very low indeed. And the instructors have a very clear system, a very clear way of being convinced that you, that 18-year-old or 19-year-old, should be put inside a multi-million-dollar piece of kit and let go, let fly. And hopefully, if they've done it right, you'll come back. So that was a really formative experience because it showed me how you teach people and how you teach people to do stuff that requires an enormous amount of risk. And then towards the end of that, I started to do a little bit of work for the BBC. And if there's one thing that is probably the most terrifying thing you can do in the world, it's being on television live with no script, which is what that show was. So that ran for about 5 or 6 years. So that just gives you a feel for what I'm like. All right. Now we come back to Dundee. So with that all in mind, what are we doing? Well, we're training the scientists of the future, or at least I hope we are. We want them to go into the world and discover things, discover knowledge, discover a life for themselves that's a hell of a lot more than, you know, working in McDonald's or whatever the hell it might be that people have as their chosen outcome in life. It's a noble thing. It's, you know, training the minds of the future. In the university, we actually have stakeholders. Those stakeholders, I think, come in 4 real flavors. The first primary one is the student. And we have a reasonably good understanding of what our students are like. Our students, or at least what it appears to be happening, is they're becoming a little bit less confident. They're becoming a lot more risk averse. We know from research that's been conducted by DTU that their maths, numeracy, you know, their ability with maths, their numeracy, their confidence with these sort of things is not great. In fact, we think about 1/3 of them have quite serious issues. We're also confident that they're not digital natives, even though people would lead us to believe that they, you know, they're basically built, you know, born into cyberspace with a computer attached to their arm. So it's a strange mix that comes in through the door, but they do have one thing, which is youth and vigor and hopefully, you know, effort and a keen desire to learn. We have the employers. The employers are the people that we're providing these, you know, students to, and they want the exact opposite of what a student's like. They want someone who's confident, numerate, prepared to take a risk, prepared to get out there and get trained, someone who is trainable, in fact. Within the university, we have the stakeholder, which is the you know, the fusty old scientists. They just want someone who can come into the lab and use a micropipette and do a t-test. Is anyone aware of what a t-test is? Do we have 1 or 2 people that are aware? And I don't mean taste tea. I mean literally a t-test, which is a type of statistical test. We've got 1 or 2. That's good. That is the #1 request from an academic in the university. Can this student do a t-test, which is probably the most primitive. And if you look at textbooks from about 40 or 50 years ago, mostly they say, well, we only present this because, you know, it's an artifact. You should really be doing something a little bit more advanced and a little bit more capable. And finally, you've got me in the bottom right-hand corner. I'm a stakeholder in the whole thing. I should at least enjoy the work that I'm doing. And this is me with a bunch of our students from first year replicating a graph of the distribution of the heights of people to show that it's approximately a bell curve. You know, because you got to get them out of their seats once in a while. People sitting in seats have a strange posture, which means they're not breathing properly, not really. And eventually they just nod over and fall asleep. And the worst place to do that is right here. And you can guarantee it's going to happen at least once a semester. So that's the stakeholders. But there are bigger stakes. So there is a crisis of confidence. Probably the most alarming thing that's happened in the last 15 years is the idea that we can't replicate the research that's been produced. And the numbers are not small. Depending on the field, it's 1 in 3 to 1 in 2. Key studies can't be replicated. Just think about that. It's almost a coin flip as to whether or not the research you think is real research is actually real research or just a bunch of fakery, a bunch of nonsense that can't be replicated by anyone. And in fact, there's been big meta-analyses where we've looked at researchers and they've reported that they can't replicate research that they should be able to, and that other people can't replicate the research that they did. So there are issues in how we actually conduct our science. Now, there are a lot of explanations for why this would be the case. One of the biggest ones is a thing called researchers' degrees of freedom. The stuff they've written down in their little methodology isn't exactly what they did. It was some, you know, idealized version of it. In fact, the 3 or 4 people that are working on the project are all using a subtly different methodology. So that could be one explanation for it. Another explanation could be that they are actively fighting the system. So they're hacking their statistics. They're hacking their experiments in order to put their best foot forward. It could be that they haven't actually had a hypothesis going in the first place, and they're just making stuff up based on, well, I saw a thing and I was actually looking for that in the first place. So that's the thing I'm going to report. That's called harping. And then the final one is just the training that people have received. So if we actually look at the academic staff, their confidence in statistics is almost as bad as the confidence of the students. So what's our goal? Our goal is to do two things. It's to get skeptics and cynics up to the point where they can get into a lab and know more about how to analyze the data than the instructors that are instructing them. Nothing makes me happier than when a student in fourth year tells me they just asked for a t-test, but I did something else instead because I thought it was more apt or more appropriate for the data. So it's great. It's fantastic. And it's not like a pat on the back or, a boop on the butt or a little pat on the head. How do we teach statistics? Well, how we do it is taking a great deal of inspiration from the RAF. We actually use simulation. If you want to train someone to do something, you have to expose them to a simulated version of it. So for example, up here we have, training pilots, training doctors, training lawyers. Simulation works. If we put them in an environment where they get to do the whole gamut, and often we get them to do it in a contracted time frame, they come out, it's a case of monkey see, monkey do. Learning by imitation. Practice is the key. So we try to instill that into our instruction, to the idea of a little simulated experiment. I'm going to show you a few of these simulated experiments now. And I can only thank the people that I work with, because they're an incredibly dynamic and creative bunch, and there are too many of them to name. But just to give you a feel for one of the experiments we did, there was this thing called Mars One a few years ago, where 400 or 500 people claimed they wanted to get signed up to get sent to Mars and never return. That stimulated an idea in a student's head. Well, the gravity's a little bit different there. How would our lungs function without that gravitational pull and that going through that vector? They designed an experiment. They analyzed the data and then they presented the results all in the space of about a week. So this was a little contracted kind of mini experiment that they conducted. Nice results too. We also built a module which took from the tenets of J.S. Haldane. So J.S. Haldane famously experimented on himself a lot. He would march up hills drawing blood. That's the kind of, the researches that we're talking about from about 100 odd years ago. And we had a module just like that. So this is Dr. Steve Land. That's me, or at least that's my hand in the top left-hand corner. And we're showing students the mammalian diving response, the drop in heart rate that occurs when you expose the face to cold water. And they conducted a bunch of little experiments to see exactly what exposure was required, whether it was just cold water, coldness, or whether wetness mattered. They came up with this neat little experiment for it. That's another one of our staff members, Art Crossman, and he is wearing a little backpack there to kind of simulate breathing. Okay, nearly done. Here's some of the results that they produced. This is interesting because it was done during the pandemic. So the students were designing and conducting experiments to check whether people were wearing masks correctly, to check whether the political attitudes associated with their understanding or knowledge of science. And there's one of our results from the diving response. Okay. What's a typical week? A typical week is about instilling good behaviors in our students. So in this very room, normally Monday at about 10 o'clock, we go through neat science that's been published in the last week. I encourage our students to read. I show them what I'm reading, and I ask them to read something and report it to me. This then translates into some kind of activity, and there will be a workshop or some sort of mixed media that allows them to engage with the topic in a different way. So it's a very rich curriculum that we present, or at least I hope we present. And it's not difficult to teach this stuff because stats is a rogues gallery. We have Galton and his strange regression graph, which is effectively, he imagined it as a bunch of pulleys. How can you not love a subject where the scientists of 100 years ago have to visualize change as a mechanical thing? We have Quetelet, who came up with the idea of the average. And if you look at his graphs, nothing's in meters or centimeters. It's in feet and pouces because it's French. It's the royal foot, the pied, and it's the royal thumb. So they don't go in feet and inches, they go in feet and thumbs, which I thought was amazing. We go down to Fisher, and of course, Fisher is a storied researcher. And we get the students to replicate those experiments too, or at least some iterations of the experiments. Now, it's interesting here, Fisher is a contentious subject, and other universities actually protest the idea that we would teach his work. There was a big case down in Edinburgh with Charles Worth on that. Okay, I think we're nearly there. The proof of the pudding is in the eating. These are some comments from the students. The first one up there makes even the most dull topics tolerable. The significance of statistics. The one I like the most is I have mixed feelings about this. Anytime someone has mixed feelings, that's good by me. Okay, final slide. I'd like to thank everyone that I work with, because if I didn't work with those people, I wouldn't be doing the kind of things that I'm doing. They promote a great environment to be in. Is that okay? Super.
Perfect. Thanks, David. Okay, we'll move swiftly on to our third presentation of the afternoon. And this time we're hearing from Professor Sudhu Paramati, who is Chair of Financial Economics and Climate Change at the university. And he's also Director of Doctoral Studies in the School of Business here at Dundee. He's a Fellow of the Higher Education Academy and had his PhD in finance from Griffith University in Australia. He's published over 65 international peer-reviewed journal articles and has nearly 7,000 citations. Amongst other awards, he's been listed in the top 35 young economists in the world, and he's also the recipient of the highly prestigious, highly cited researcher award from the Web of Science, that's Clarivate, for the year 2022. So I'll hand over to Sudhu, who's going to talk to us about how we ensure energy security and meet net zero targets. Sudhu.
Thank you very much. Good to see many of you. We usually see students, but now we have a wider audience. That's really exciting. So in today's topic, I will be talking about what is energy security or energy poverty. And then I will also talk about net zero emissions. So now let us try to understand what is energy security. Before even I go there, let me try to, tell you my own background. Why did I move to energy related research area? My PhD was in finance area. I was doing in Australia, and then I was almost completed my PhD, and that's when the Paris Summit was on climate change in December 2015. And that really motivated me to work on the climate change related issues. And then I began to explore research on energy related, and that's how I moved to energy related area. Of course, I still do research on portfolio diversification in finance area, but again, my focus is on climate change issues. So now let us try to understand what is energy security and what is energy poverty. Again, remember, there are millions of people in the world, even we are in now 21st century, there are millions of people who do not have access to electricity. And you can't believe they never experienced electricity in their houses. Still, we are living in 21st century. There are millions of people. As per International Energy Agency, there are nearly 770 million people who never had access to electricity. And in the sub-Saharan Africa, almost 50% of the population do not have access to electricity. So one is, there is an issue of energy supply to the people, particularly in the rural areas. And then again, remember, if you recall a couple of years ago when this Ukraine-Russia war started, the energy prices shooted up. More than 100%, more than 200% electricity prices increased. And this was a major issue for the people, those who are in low income category. Obviously, they were not offered to buy the electricity. And even in the peak winters, they were not utilizing the electricity to heat their houses. And this is very, very important issue to understand what is energy security and how we can tackle that issue. And then we talk about net zero emissions. Just look at this picture. No electricity. And remember, electricity is connected to all sort of economic activities, directly or indirectly. It has a huge impact on the employment generation. It has a huge impact on the earning opportunities, and it has a huge impact on the even education. Look at this picture as well. And remember, there are millions of people who do not have access to clean fuels. I'll try to provide you more statistics on what percentage of global population have access to the clean fuels. So in this bar chart, you can see here, this is the access to electricity of the global population. And I try to compare from 2000 to 2021. So that's a 22 years period. And if you look at the left-hand side, in 2000, only 67% of the rural population had access to electricity if you consider the global population. And that has increased from 67 to 84% by 2021. And in the urban areas, it was almost 95, and that increased to 98%. And if you consider the whole population, both including rural and urban, we had only 78% of the population access to electricity in 2000, and that has increased to 91% by 2021. And another interesting statistics here, access to clean fuels for cooking. Remember, in the rural population, in 2000, only 24% of the rural population had access to the clean fuels. Otherwise, they might be using kerosene or firewood for cooking. And that has increased to 51% by 2021. So you can see that more than 100% increase in terms of access to the clean fuels in rural areas. And in the urban areas, it used to be 76% of the population, and that has increased to 87%. And if you consider the whole population access to the clean fuels, we used to have only 49% in 2020, and that has increased to 71. So you can see that almost 50% or 45% increased access to the clean fuels by 2021. And let us also look at the statistics on low income, middle income, and higher income. And how does it look like, access to the electricity? So if you look at the low income countries' population, access to electricity was only 16% in 2000, and that has increased to 45% by 2021. And in the middle income countries, and almost 78% of the population had access to the electricity in 2000, and that has increased to 95% in 2021. And if you look at the high income countries, almost 100% across last 22 years. Again, if you look at the access to the clean fuels for cooking in the low income countries, look at here. In 2000, there was only 9% of the low-income population had access to the clean fuels for cooking. And that has increased to, again, only 16% of the low-income population by 2021 have access to the clean fuels. And in the middle-income countries, and that has increased from 40% to 72% during 2000 to 2021. And then in high-income countries, almost 100% for access to the clean fuels. So now, what do we understand? We are talking about net zero emissions. But at the same time, two sides of the coins. One side, we are talking about the net zero emissions. On the other side, people are still struggling to have access to the electricity. So here, the main causes for energy poverty is lack of investments into energy projects. That's the fundamental reason. But again, you may ask, why there is a lack of investment? Again, remember, these low-income countries, particularly the governments, are trapped with the poverty. And when they don't have a proper electricity, obviously all the economic activities are linked to the energy. If there is no energy, then obviously they will not be able to produce the economic output that is desired, that is needed. And therefore, there is a lack of investment into energy projects, and obviously the public-private partnership investments also very, very less in these countries. And also another major issue is that increasing geopolitical tensions among the nations. That is also one of the reasons, as I said, like when the Russia-Ukraine war started, and all the people have to pay for it. Energy prices increased by 200%. And many people were not offered to pay the electricity prices those days. And at least, it is now coming down slowly. And energy poverty leads to more unemployment And then again, that leads to more poverty, imbalance in terms of income distribution, and low economic prosperity, because all the economic activities directly or indirectly linked to the energy. Now let's look at, we talk about net zero emissions widely and everywhere in the media, in the televisions, everywhere we talk about emissions. But now let's look at this particular graph. If you look at the emissions that come from China, India, and US, only 3 countries we are talking about in the world. And these countries used to contribute more than 42% in year 2000. And that is keep on increasing, and that is now somewhere over 50%. So 50% of the global emissions come from only 3 countries. You can imagine how much emissions they generate, and that is affecting the entire planet. So now let's look at the growth, particularly these 3 countries as well as the world. And you can see that the emission growth in China from 2000 to 2020, you can see that it is continuously growing. You can see that it has increased by almost 300% by 2020. And you can also look at that emissions from India, it is also increased. Again, remember, please don't look at the last one, 2020, that was the COVID period. And that is why emissions were low across the globe. And that is why you may see that it is coming down, but in reality, it may not be true. Look at the EU member countries' contribution to the global emissions. They used to contribute in 2000 nearly 14%, and that has come down to, let's say, approximately 7%. But again, here, the basic question is the emission coming down in reality? Why emission is coming down in the EU member countries? It is mainly because of 2 reasons. One is they began to invest so much money into renewable energy projects, and obviously they have more access to renewable energy. This is one. And again, remember, all the polluted industries are completely moved out from these countries to developing countries. And all the manufacturing is coming, like whatever the goods that we buy from the grocery stores, they are made somewhere in China or India or somewhere in developing countries. So these polluted industries are completely moved out from these European countries to the developing countries. That is why the emissions are significantly declining in EU member countries. Now let's look at the comparison between the high income countries and middle income countries in terms of pollution contribution in terms of the global share. You can see that there was a convergence in 2005 around. So you can see that in 2000, the high income countries used to generate nearly 53% of the global emissions, and that is slowly coming down to less than or around 37% by 2020. And on the other hand, if you look at the middle income countries, and it used to contribute like roughly 41%, and that has increased to nearly 64%. So now what we can sense is that the emissions in middle income countries is growing day by day. On the other hand, the emissions from high income countries is coming down. As I mentioned, there are 2 reasons. One is that they began to invest more money into renewable energy projects, and also they began to remove all the polluted industries to the developing countries. And that is why you can see that there is a drastic fall in the CO2 emissions in high income countries. So if you look at the global picture, and where the pollution is highly concentrated, you can see that China, India, and the Russia, and on the left-hand side, you can see that US and Brazil, and here on the bottom, you can see that South Africa as well as Australia. That's where the majority of the pollution come to the entire planet. So now we looked at the poverty, energy poverty, and we looked at the global emissions and where that emission come from. Now, what are these international organizations are doing in order to mitigate the global emissions? So obviously, the United Nations is proactively supporting the developing countries to engage more into clean energy projects. So they began to pump lots of money into these developing countries in order to reduce the carbon emissions. And this is in $1 billion in 2020 constant prices. And you can see that the capital flow, financial support for clean energy projects in developing countries is increasing. And particularly if you look at the 2015, that's when we had the Paris Summit on climate change. And you can see that since then, suddenly shoot up in terms of the financial support for the developing countries and clean energy projects. And then after 2017, again, due to some governmental issues or geopolitical issues, and that began to fall. And then COVID also adversely affected these capital mobility to the developing countries. So impact of pollution and net zero emission targets. Again, remember, these emissions are having a huge impact on everyone. Remember, it's not, let's say, for example, if China or India are emitting more global emissions, it doesn't mean that it will only affect them. It will affect everyone who lives on this planet, directly or indirectly. So if you look at the statistics, household air pollution was responsible for an estimated 3.2 million deaths per year in 2020. So you can imagine how many people are dying just because of this pollution. We are talking only about household air pollution because of lack of clean fuel usage for cooking, including 237,000 deaths of children under the age of 5. This is because of household pollution. The combined effect of ambient air pollution and household air pollution are associated with 6.7 million premature deaths annually. So you can imagine how this pollution is affecting people, and how many people are dying because of the high level of pollution. Net zero, again, we are talking about net zero emissions. Again, it basically means that cutting greenhouse gas emissions to as close to zero as possible, and the rest of the emissions will be absorbed by the forest and ocean. And in the Paris Agreement, that was December 2015, almost 195 parties agreed to reduce the emissions by 45% of their emissions by 2030, and then net zero by 2050. But again, are we on path to reach that target? Again, it is a question, because these days, particularly in the last few years, the geopolitical tensions are increasing across the globe. Again, remember, when there is a geopolitical risk is rising, then obviously countries have a less interest to focus on climate change issues, and they will not be able to fund the projects that is needed in order to reach these targets. So there are several challenges in order to achieve the net zero emissions. COVID-19 definitely had a huge negative impact on these emissions. And COVID-19 has a huge impact on these renewable energy investments, and increasing geopolitical is another negative factor for these reaching the targets. With increasing financial constraints, governments have been showing less enthusiastic on climate change issues in the recent past, as I mentioned, due to various reasons, and COVID and these geopolitical reasons also two important reasons for this outcome. In order to improve the energy security and achieve net zero emissions, the global institutions, particularly the United Nations and World Bank, and major players should continue to provide the needed financial and technological support for the renewable energy projects in developing countries. That's where the emission is coming mainly from, in order to reach our target. So here, again, remember, we are talking about two important issues. One is the lack of energy supply to the people, and on the other hand, we are talking about increasing pollutions and how we can mitigate the pollutions. So this is what my research mainly focuses, and that's what I do. Thank you very much.
Thank you, Sudhu. We'll invite you perhaps to join one of the hot seats with David and Anne here at the front, and I'll invite some questions from the audience. Please, when you have a question, just wait for the microphones to come your way. So Marios first.
Thank you very much. I have a question for Sudhu and for Anne. You presented very clear evidence that the relative proportion of emissions in different groupings of countries are changing in very different ways. Considering CO2 is a volatile gas and it affects the whole planet, what's surely more important is what's happening to the global emissions. So is that as optimistic as the availability of electricity? That is clearly a very positive message from your talk. Or is it as negative as the increase 3 times over the last 25 years that China has given? So that's the question for you. And I'll ask both questions.
Yes, I suppose, Marius, and then.
And for you, the question that I had was, you said I blame CSI and NCIS and all of these shows for misunderstandings. I would like to hear your perspective on the real effect that the courts experience from the audiences being educated or miseducated by programs such as these, and expectations that, is there a disservice being done by all of these, and what can be done to improve the quality of the general public's, the jurors' ability to interpret science data, because this is clearly an important element. So these are the questions. Thank you.
Sudhu, do you want to go first?
Yeah. So again, we're talking about electricity car, for instance. And again, remember, even if we use the electric cars, we have to understand where that electricity is coming from. Let's say China, India, they are widely talking about, promoting electric cars because of high level of pollution in the urban areas. And they are not paying attention to the electricity generation, where that is coming from. If they are using coal or oil to generate the electricity and use that electricity to run your car, it doesn't make really any sense. So obviously they need to understand that they have to invest on the renewable energy projects and generate the electricity and use that electricity to run your cars. Otherwise, it will continue to have a negative impact on the environment. And similarly, we're talking about energy security, and obviously we're not talking about fossil fuel based energy or electricity. We're talking about clean energy, renewable energy. That's what we want to generate, and that's what we want to supply to the people, so that it will not have any negative impact on the society. At the same time, it will also have a positive impact on their economic development as well as their earning opportunities. So that's the point.
Anne.
Yeah, there really is an impact that has been seen in court. We've had discussions with prosecutors, not just from Scotland, but from around the world, who have said that in their opening arguments, if they're not leading DNA evidence, they actually have to explain to the jury that they're not going to do that, and the reasons why, because there's an expectation that there will be DNA evidence. It's a wonderful thing, and yes, it can assist in putting an individual at the crime scene, but I talked about some of the problems with that. That's just one example. The people come in with misconceptions around, well, why didn't you analyze that? Well, actually the science, or is it yes or no? Was that a match for the fibre? It's never that straightforward. There is always, well, it could be a match. It's a cotton blue fibre. What's denim made out of? How much denim in the world is there? Could you say that fibre comes? There's always some level of you have to put the context around the evidence and what it means into that situation. I said here that I blame these particular shows. That's not just one avenue. I mean, even you look at the news, they report the good stories, or DNA has nailed this individual, or whatever it has come to. But we have to remember that at the end of the day, it's a piece of evidence that has gone into the court, and the jury are making, or the judge is making the decision based on a lot of information. One of the things I used to do with training scientists, and this is the way we can look at it, is actually make them go and listen to a judge's summing up, so that they can understand that, yes, you might have had quite an important or a strong piece of evidence. That's not the only thing that we're in that court for. Very, very rarely will any prosecution be taken on one single piece of evidence. So I think there's an education for not just the general public around some of the realities. There's education around forensic scientists and how to communicate more effectively to juries. People are scientists at heart. You have to be to do that work. That's where you start. Not every scientist is a good communicator. So some very complex things, how to do that. How can listening to judges, listening to practitioners, listening to law enforcement, what do you need to know and how do you need to know? And it's getting everyone together and bringing them together and having those conversations early on is really important. And things are being made. And this is something that Leverhulme Research Centre is really driving, is bringing all those individuals and stakeholders together, including the general public, about, what's the future going to look like? What perhaps should we strive for? What do you want to see and how do you need to see that being developed?
Okay, we've got a question from Inka here at the front, but while the microphone gets to you, Inka, I'll just ask a question of David that's coming online. So, David, how good are we as a university at using statistics to accurately track our performance on things like tackling race and gender inequalities. And I think that might be getting at things like student attainment gaps, for example. And I don't know what work you're doing in the school at tracking attainment gaps by different protected characteristics.
What am I doing? Well, let me put it like this. One of my goals was, can I get our students up to the standard where they could probably interpret data better than the management? And could they conduct surveys?
Difficult, David.
No, not fantastically. No, honestly, I don't. I think we suffer on the data front because people don't have the confidence or the ability or the hubris to say when they can't do it. So, for example, with things like attainment gaps and issues associated with discrepancies, not even biases of one type or another. People are very keen to hone in on percentages and numbers, and what they're not so keen on looking at are the odds of things and the uncertainties in those odds. So it's okay saying, one group is 4% smaller or 4% lower than another group, but what happens if the errors on those differences are, 2 or 3 times larger than the difference between them? So, and I've seen quite egregious things egregious claims being made in reports that have been presented at the university on matters of exactly that. Well, I mean, I'm not going to go any further, but you get the idea. Yeah. The final thing is, in terms of attainment gaps, I'm uncertain as to how we're actually estimating. I've proposed a few ways to do it. I mean, we have a raft of data, a whole wealth of data, where we could quite happily go in and interrogate it for exactly the kind of things that people are interested in. And certainly we've used it primarily with actually Dr. Brewer when it came to the impact of the intake that we get from further and higher education colleges. So we take on a bunch of students from MD40 and MD20 backgrounds, a bunch of students that have gone through unconventional routes. And we want to know, well, how do they perform in the grand scheme of things? And obviously they're not going to perform as well as someone who's come straight through on the right levels, come straight through on their advanced tires, as a high flyer from the start. But you've got to consider the idea that, is this giving a person an opportunity to get, a degree and an opportunity in life that they wouldn't have had before? And sure, the numbers might not be, like 80, 90%, they might be 60, 70, 80% instead, but actually interrogating the data that we have, which is we have this big database, where everyone came from and what they achieved on the way out and what their entrance grades were. And, so we've actually used that data for smaller reports, but not big grander ones. But I assume Harry Handal is on the case.
Yep.
And I'll be intrigued to see exactly how it is that because he said more than once that there is an attainment gap. But I've yet to see any figures or any methodology associated with how those figures were arrived at. And then
sounds like
it gets worse. Once you've seen the gap, the question is, why is it there? What are you actually looking at? Are you looking at bias? Are you looking at cultural things? Are you looking at a curriculum that, inverted commas, needs to be decolonized? What is exactly causing the thing that you're seeing? And if you believe that you can answer that question just by looking at data, then you're on a hide to nowhere, or at least that's my opinion anyway.
Thanks, David. Inka.
So that was a beautiful segue into your question that actually, I think what was just asked, and I don't know who was, it actually illustrates how useful it would be if we had more input of this type of expertise. And so my question is actually going that way to David and really also to the other two is because Sudhar and Anne, you talked about, will also require that type of knowledge and that type of analysis. So my question to David is, how can we not just educate our students? When you alluded to this, all our staff, are there ways that you can use the terrific approaches you've used? Are there ways we as a university can use that expertise and that enthusiasm to maybe help train beyond our borders to create a more educated public in this space to have this relevant knowledge? And I wonder what your ideas would be on that.
We've spoken about this several times. I think our public engagement strategy is impoverished at best. Look at how the big players do it. MIT, they have single lectures on YouTube that have over 4 million hits. And they're not about topics that people would find, superficially interesting. This is like hardcore physics 4.5 million views on a single subject. Admittedly, it was by Walter Lewin, who's like a fantastic communicator. But then you flip to the other side, and you've got someone like Gilbert Strang, and he's teaching linear algebra, and it's got like 1.5 million views. And the question is why aren't we doing something similar? Why aren't we using the resources that we have available to us and producing an outward-facing stage so that the world can see exactly what it is that we do? I find it very strange. And if you look at our strategy for digitizing the lectures that we have, it's so ad hoc. It requires, if you're lucky, having a webcam mounted on top of that. If you're really lucky, you've actually got a proper system in place and it can capture it in some meaningful way. If you're unlucky and you're in one of the other rooms, it's a webcam dangling on a stick. And it's all ad hoc and it's all, you know, stored for only 1 year. When what we really should be doing as a university is having some kind of process in place where we take every single one of the modules that we have and generate a resource for the world, just like MIT. If you flip even locally, you look at like somewhere like Nottingham. I mean, they have 4 YouTube channels. 60 Symbols is one of them. Computer File, Number File. These are enormously popular things that give that university such a large, you know, such a buff to their reputation. That I think we should be doing something similar. And when I hear that our strategy involves going out to primary schools and talking to them about proteins, I'm shocked. I'm a little bit shocked. Now, internally, we've spoken about this as well. So during the pandemic, our school decided to do loop-mediated PCR. So they were going to test about 50 people continuously over 10 weeks and check to see whether this was a good strategy for actually tracking, you know, a disease in our population. Now, David Spiegelhalter, the famous great David Spiegelhalter, had many a Twitter post about the dangers of those sort of testing techniques when you've got a low base rate of a thing occurring. It's a thing called the fallacy of the base rate. If you only have 4 or 5 cases, most of them will be false. And you'll miss the one, you'll have false negatives and false positives that are actually outnumbering the truth of the data. And the students on the BS 21009 course actually generated a Bayesian approach to determining what would probably happen when SLS did this. And I sent that to you in an email.
We should probably move on. We probably have time for one more question before we have to break. Is there another question that someone's desperate to ask? Doreen.
Hello, Sudhu, it's for you. I really liked that point you made about the fact that we have our emissions are going down because we're sending all our polluting industries. And I think the fact ours are going down, say in the UK and Europe, makes us all complacent. How can we, there must be some simple formula that could be used to say, okay, in the UK, these are the emissions you use, because what you do, you factor in what we're importing from polluting countries so that people in Britain can be told, this is what your emission really is. You may think it's low, but actually it's not, because you're buying your electric car from China. You're buying your, you know, it's being shipped here on a boat that is polluting the planet. Is there a way we can do that?
So again, in terms of measurement of the pollution, yes, of course, what regulators are doing is that we have at the company level now, the emissions are accounted, how much emission each company is generating, even within the UK. Yes, we do have that measurements. We do research at the farm level and we do research at the country level as well. So when we do at the farm level, and then we try to investigate what motivates a farm to cut down the emissions. Let's say, for example, if you're polluting a company, then obviously when they go for financing from financial institutions, at that time, the cost of the financing will be slightly higher as compared to the non-polluting farms. And similarly, there are some penalties that government can impose on these polluting companies unless they implement everything properly. So we do have measurements, and particularly I'll talk about a recent paper that we have written. And we talked about, let's say, for example, if we have a proper gender diversity within the corporate boards, how that will affect the emission level of a particular company, because we believe that women is more caring of environment than men. So we want to see the role of women in the leadership role, and then how that affects in terms of promoting the renewable energy uses at the farm level, adopting more green technology at the farm level, and mitigating the carbon emissions. Yes, we do that research, and we do have a measurements to account for both direct and indirect emissions.
Okay, we've had three such fantastic presentations. I'm sure we could keep going with questions for a long time, but we really do need to finish here. So we're breaking for coffee now. So please do come back at 3:15 for the Stephen Fry Public Engagement Awards. But in the meantime, can you please give a round of applause to Anne, David and Sudhu for some fantastic presentations.